Okay, last part of Notes 8.4. Now we're sort of in Part C, area. And once again, I've talked a little bit about area on page 1 of your handout. Area is measuring flat space, two-dimensional space. Like if you wanted to know how much space is on your tabletop, or on the floor, or a wall, or a photograph. So there are a lot of formulas, but we're actually just talking about the idea of area, which is not measured anymore in linear units. Area is measured in square units. So I want to talk about that for a minute. On the first page of your notes, I talked about a square mile, but a square anything, if I had a good thing to picture is like a tile, like a floor tile. Often they are 1 square foot, which is why the size of a home or a room is often given in square feet here in America. So we say this tile is 12 inches by 12 inches or a foot by a foot. So this whole thing, a square, represents a square foot. And we write it either like this, since the exponent 2 is, we call it something squared, or you can actually put SQ for square and then FT for foot. Typically the FT to the second power is the way that we do it. So it doesn't make sense to answer an area problem with inches or feet or yards, but rather square feet, square yards, square meters, and the like. So if you're looking for area of a shape and it's on a grid, depending on the size of the grid, it would determine the area. But it says here the squares on this grid are 1 centimeter by 1 centimeter. So that means they're all square centimeters. Well, all you have to do is count them up, and as you can see, there's 8. So this is 8 square centimeters. That's the area. Area is 8 square centimeters. No work to do, just count. Now you can see the general, the reason why we would need a formula is not every figure, number one, is placed on a grid, or is it convenient to put on a grid, but also the little squares aren't always full. You may have a portion of a square in a particular shape. So let's keep going. Here's another one. It's still not very challenging. It's a bit more complex, but to find the area, again, you just count. All the squares are fit into it nicely, so it looks like I've got 2 more thrown on. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So area, we use a capital A to denote area, is 10. And in this case, I'll assume in this example it's still the 1 centimeter by 1 centimeter. So we'll say centimeter square. If it didn't say at all, we would just put the word unit and then the power 2 and call it unit squared. One chunk of your homework has triangles on it, and especially when they're right triangles like this. But when you have a triangle, you don't really have to estimate all the little bits, because you can see here you've got kind of a little portion, a little bit, a little teeny tiny bit, and instead of approximating that, if you just make a rectangle out of the whole thing, it really is harder to write on the smartboard than it looks. Pencil doesn't always go where you want it to. But let's just find the area of the whole rectangle, and then we just want half of it. So we'll take half because we just want this part. So the area is going to be half of the rectangle, just abbreviate rectangle. And so the area of the rectangle, you see it's 1, 2, 3, 4, 5, 6 across, so it's 6 times and then 1, 2, 3, 4, 5 vertically. So that means there's 30 squares in that rectangle. So half of 30 is 15. And this one doesn't give the units here, so let's just go ahead and say units squared, since we don't know how big each one of those little grid squares are. The way I've shown my work here is how I would like for you to show your work as well. So when you can do something like this, it is a great idea. Works nicely. And we're not really having to approximate. So this is actually exact. So I'm going to write that over here, because on some of our problems we're going to have to round. So in the green box, I've said, well, when the figure is irregular, you know, some funky shape, or maybe it's just kind of not laying on the grid the way that we can simply count, then we're really going to have to estimate. So I've listed some steps here. Obviously, we'll count up our complete squares, and then we'll count up the halvesies and sort of put them together and get our wholes to add on to step 1. Then there's going to be some squares that look like they're a little over half, some that are under, and we're just going to try to put the pieces together to add up to equal a square. So we're really truly going to be approximating. We're estimating. I like to use some colored pens and pencils for this, and or highlighters. I suggest you do the same. It makes it actually a lot easier. It's a little harder, it's easier on paper than it is up here, just because my marker is kind of too big. But let's go ahead and just number the squares that are whole or just about almost whole. Okay, so for example, this first one right here, I'll just put a 1 in it. Well, can't see that very well, can you? Of that. There's a 1. It's almost whole, so I'm going to go ahead and count it. So I'll just number 2, 3, 4. I go ahead and count this one. It's almost whole too. 5, 6, 7, 8, 9, 10, 11, 12, 13. So my area starting off is, actually we need to use the approximation symbol, is 13. And then I've got some other pieces. So let's look and see. It doesn't look like we really have any that are just half. But what I do is just try to piece some together. For example, I might look at this one, these 2 pieces, and I'll kind of, I have to kind of shift to the right on this. I'm going to get rid of the 13 that we numbered, and maybe I'll just try to highlight that. Let's see if that works a little bit better. So we counted all of this part already. Come on. It's not liking me, kids. There we go. That's as well as I can get it. So I'll use a different color on the other parts right here. So I sort of need to put some together. So like these 2 looks like it's going to go together and kind of give me another one. And then maybe over here, I'll get a different color. This piece and this piece go together to give me another one. And then, oops, just black. These 2 gives me another one. And then this little corner down here, I'm limited on my colors here. There's another one. Blue up here. I've really got this little tip and still this little piece right over here. So that's really another one. So I've got approximately 13, 14, 15, 16, 17, 18. So I would say my area is approximately 18. And up here it says, estimate the area if each square is 1 square foot. So all of our answers here will be square feet. So 18 square feet. Let's try one more together, and then I'd like for you to try some by yourself. So we'll try this one right below it. If you just glance at this one, just to review a little bit, it looks like it is a parallelogram. It looks like a rhombus. Let's count all the ones that look like they're whole. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now I'm looking at this one. I definitely have a lot of little halvesies. So this one is a lot easier for me to put together. In fact, it looks like all of the little leftovers are halves. So I'm going to write here the area. So far we've got 12. And let's see how many halves we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, if we've got 12 halves, that's 12 times a half. So 12 times a half is 6. So again, we've got 18. Did I count that right? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Well, I may just have 11. No, let me see. Let me do that one more time. I'll mark them with a green this time. I've got 2 here, 2 here, 2 here, 2 here, and then I've still got 4 left over. So that's another 2, another 2. It's 4, 5. Yes, that's right. So it's 18. Just double checking, folks. Square feet. And this one is actually, we're not really approximating. This one is exact because those are cutting the little squares in half. I guess they're not exactly half. Maybe we'll go ahead and approximate, but they're very, very close. Very, very close. So go ahead and try the other 2 to the right, and then come back with me on the video. Okay, so let's take a look at this first one. The yellow is the part I would have numbered. So the yellow, the holes, I counted 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then I just sort of tried to color code the others that I put together to equal 1. So I had this little green corner. That's +1 right here. And then this little hot pink, these 2 go together to make about 1. And then this little little blue chunk right here, they went together. And then this little red piece with this other red piece that took up most of the square gave me another 1. So again, I need to say approximately. So 14, 15, 16, 17, 18. Again, the popular answer. Approximately 18 square feet. Now I want to show you a different strategy on this next one down here. Another option you can do is sort of like the one we were doing with the triangle, where we were making a rectangle out of it, except we're not going to be doubling. One thing you can do is you can make a rectangle around the figure, and because you know you can find the area of the rectangle, and then you could just subtract. It might be easier to just subtract the white part than it is to count up all the parts inside. And I'm going to try that one more time. I don't think my board is calibrated correctly, so I'm having to sort of compensate. I'm really a good tracer, but having to write further to the right than what it looks like. I apologize. This is just barely better. But go ahead and try to count up. It might actually help you to shade in the figure in the middle, and then count up what's around the edges. So, because it looks like, you know, to me, over here, like in the left corner, I've got one, and then I've got this little half and this little halvesy. So this little corner over here has got two white spaces. Same thing over here in this corner, looks like two. And the other ones are a little bit different. Looks like over here, I would probably put this little corner down here and this little piece together to make one. And then maybe, yeah, this piece over here together with this piece to make one. And then just like we did over here, kind of take this little corner and this little piece right here to make one. So the ones I've shaded in all together in this corner, I had the two green, and then the two blue went together for one, and then the two black went together for one. So those are all the ones I want to take away. So let's say my rectangle, I'll say minus, I'm going to put minus the white part, because you could have shaded in your whole figure on the inside to make it easier to see. So the whole rectangle is 4 by 1, 2, 3, 4, 5. So it's 4 by 5. So it's 20 minus 2 plus 2 plus 2 plus 1 plus 1. So that's 6, 7, 8. So it's 12 square feet approximately. If you look at my key, my coloring looks really good, and it will make it a lot easier for you to tell sort of how I put it together. Okay, oh sorry, I was just looking at my notes there for a second, seeing the mistake I made on them. So the last two, we're actually just drawing a trapezoid that is approximately 8 units square. So you might just try something and see. So I would pause the video, try 15 and 16, and then turn the video back on and see what we come up with. Okay, if you look at the trapezoid is really pretty easy. Mine doesn't look perfect. Again, if you look at my notes that I posted for you, my key will look better. But there's 6 squares, or actually 7 squares, and then 2 halves of a square. So that gives me approximately 8. Now the circle, I tried to draw on the Smartboard. It wasn't working very well. It looks a lot better on my notes there. So just check that out and you'll see it looks like a radius of about 2 squares. A circle with a radius of 2 will give you approximately 13 square units. So let's just make a note here. See my notes key posted. And these will take you a little longer than what you were doing with the circumference and the perimeter, but that's okay. Just take your time, and you really do need to get some colored pencils or pens there to help you out. So have fun concluding our geometry unit.